Welcome to our comprehensive guide on SQL joins. Today, we'll explore the various ways to combine data from different database tables. Joins are fundamental to working with relational databases, and understanding them thoroughly will make you a more effective data professional. By the end of this presentation, you'll be comfortable with all types of joins and know exactly when to use each one. These learning objectives form the foundation of our journey through SQL joins. We'll start with basic concepts and progressively move to more advanced topics. Each objective has been carefully chosen to ensure you develop both theoretical understanding and practical skills. The knowledge you gain today will be immediately applicable to your data analysis work. Our journey through SQL joins follows a logical progression. We'll start with the fundamentals and gradually build up to more complex concepts. Each section builds upon the previous one, creating a comprehensive understanding of how joins work and how to use them effectively. Feel free to take notes, and don't hesitate to ask questions as we proceed. Before diving into specific join types, let's understand what a join actually does. Think of it like combining two spreadsheets based on a common column. For example, if you have a table of customers and a table of orders, you might join them using a customer ID to see all orders for each customer. This fundamental operation allows us to work with normalized databases effectively. The inner join is probably the most commonly used join type. It's like finding the common ground between two datasets. For example, if you join employees and departments, you'll only see employees who are currently assigned to a department. Any employee without a department or any department without employees won't appear in the results. This is perfect when you only want to see complete matches between your tables. The left join is crucial when you need all records from one table regardless of matches in another. Imagine you want to see all customers and their orders, including customers who haven't made any orders yet. The left join ensures you see all customers, left table, with null values for customers without orders. This is particularly useful for finding gaps in your data or ensuring no records are missed from your primary table. The right join is essentially the mirror image of a left join. While less commonly used, many developers prefer to rewrite them as left joins. They're still valuable in certain scenarios. For example, if you want to see all departments and their employees, including departments with no employees, you'd use a right join if the departments table is on the right side of the join. Remember, you can always rewrite a right join as a left join by switching the table order. A full outer join gives you the complete picture of your data relationship. It returns all records from both tables, with null values where there are no matches. This is particularly useful for data analysis and finding mismatches between tables. For instance, if you want to audit the relationship between customers and orders, a full outer join would show you both customers without orders and orders without valid customers, potentially highlighting data integrity issues. The cross join is a special type of join that creates every possible combination of rows between two tables. While it might seem unusual, it's actually quite useful in specific scenarios. For example, if you have a table of products and a table of sizes, a cross join would create all possible product size combinations. Be careful though, the result set size is the product of both table sizes, so it can get very large very quickly. The self-join is unique because it joins a table to itself. This is particularly useful for handling hierarchical data like employee-manager relationships, part assemblies, or family trees. The key is to use different aliases for the same table to make it clear which version of the table you're referring to. For example, in an employees table, you might join it to itself to find each employee's manager's name. While natural join might seem convenient since it automatically matches columns with the same name, it's generally considered risky in production code. The problem is that it makes assumptions about your schema, and if column names change or new columns are added, your query behavior might change unexpectedly. It's usually better to explicitly specify your join conditions. Consider this a feature to be aware of, but use with caution. Semi and anti joins are conceptually different from other joins because they only return rows from the first table. A semi-join is like asking, "Show me customers who have placed orders," while an anti-join would be, "Show me customers who have never placed orders." These are particularly useful for filtering data based on the existence or absence of related records. They're often more efficient than regular joins because they don't duplicate rows. These best practices are crucial for writing maintainable and efficient join operations. When working with joins, think of yourself as an architect designing a pipeline. Every decision impacts performance. Using clear aliases makes your code more readable. Proper indexing can dramatically improve performance. Filtering early reduces the data volume you're working with. And selecting only necessary columns helps optimize memory usage. These aren't just guidelines, they're the difference between a query that runs in seconds versus minutes. Query optimization is both an art and a science. The query engine tries to optimize execution automatically, but it needs our help. Understanding how to structure your joins efficiently can make the difference between a query that performs well and one that brings your database to its knees. Always think about the order of operations. Filtering early reduces the amount of data you need to join. Proper indexing is like giving your database a roadmap to find data quickly. And always verify your optimizations using explain to understand exactly how your query is being executed. Being aware of these common pitfalls can save you hours of debugging and performance issues. A Cartesian product can explode your result set size exponentially. Always check your join conditions. Missing indexes are like trying to find a book without knowing which shelf it's on. Implicit type conversions can silently kill performance. And using outer joins when inner joins would suffice adds unnecessary complexity. Remember, every join should have a clear purpose and be properly optimized. We've covered a lot of ground in understanding SQL joins. Remember, choosing the right join type is crucial for both getting the correct results and maintaining good performance. Think of inner join as your default choice, and only use other types when you specifically need their behavior. Left join is your go-to when you need to preserve all records from one table. Full and cross joins should be used sparingly and with careful consideration of their impact. Practice with these concepts, and you'll become proficient at data manipulation in SQL. Thank you for attending this presentation on SQL joins. Remember that mastering joins is a journey. Start with simple queries and gradually work your way up to more complex operations. Practice is key, so try these concepts out with sample databases. If you have any questions, now is the perfect time to ask. Keep exploring and experimenting with different join types, and you'll become more confident in your database querying skills.